Okay, good morning. Welcome to another wonderful day of right triangle trigonometry. We are on homework 8.4, angles of elevation and depression. And as you'll see, I actually have here a full complete version of the homework because I already went through it once in a video and had some technical difficulties. And so this is my second try. I thought I'm not going to rewrite it all. So I'm just going to talk you through what I've completed here. I'll do some of the calculations right on point with the calculator. But 8.4, homework. We're simply applying what we've learned with right triangles, SOHCAHTOA, to basically word problems. Pictures like this where angles of elevation and depression, where something smaller is being compared to something larger, that creates a right triangle, and we're able to apply an angle and then opposite, adjacent, and hypotenuse sides. So let's get to the definitions. Just two definitions, angle of elevation, angle of depression. They're basically the same thing except in opposite directions. The angle of elevation is an angle formed by looking up from a horizontal line. So this small guy looking at this amazing giant double scoop ice cream, he's seeing it at an angle of elevation. Here's the horizontal line and then the angle up. So whatever these degrees are, that's the angle of elevation. It rises up from a horizontal line. Whereas the angle of depression is an angle formed by looking down from a horizontal line. So the ice cream is viewing the man from whatever angle this would be, horizontal from its line of sight downward. That is an angle of depression, and you'll have problems with both. One is a smaller thing looking up, another thing is oftentimes a larger thing or something at a higher height looking down. But the key is it's always down from a horizontal or up from a horizontal line. So pretty simple. Make sure you include a definition. The other thing is keep in mind these always form what kind of triangle? A right. So here's our little right angle right here. A right triangle because we're using SOHCAHTOA, and that is right triangle trigonometry. So you're going to always want to form a right triangle with these drawings, with these angles of elevation and depression. So first question. First question was, what's the first step you should do in trying to solve one of these problems? And that is what I've already done up here and what I've done down here when we get to question number 2, and that is draw a picture. If they haven't already given you a picture for the problem you're working on, you should sketch it out. And as I said, it'll always involve some kind of a right triangle because all you're really doing is right triangle trigonometry. So draw a picture should include a right triangle, and that's what we have here, and that's what you'll see when we do number 2 has been created here. So question number 2 is a typical word problem that you'll have from this chapter, and that is that you have a plane coming in for a landing at an airport, and it says it's at a 3-degree angle of descent. It tells you that the plane is at a height of 1,770 feet, and the question is how far is it from the airport? So I sketched this out. You got the airplane higher above coming down to the airport. Its angle of descent, this is the key point, this is an angle of depression. So from a horizontal line down, it's going at a very shallow angle of 3%. So we want to make sure that 3% gets to the right spot. Then it was up to me to just turn that angle of depression into a right triangle where I know one of the dimensions. I know the height, so I know this dimension, and I need to find another dimension, which is this line here, because that's how far straight across. I know it can seem like this distance here, but just read the question carefully. That's one of the, try to reason it out, but it's this distance from between the plane and the airport that we're trying to find, the x. So that's the first step that we talked about here. Draw a picture, and you can see this is just a triangle problem. I know the angle, I know the opposite side, I don't know the adjacent side. And if you say it that way, you then get the clue as to which ratio you should be using. I have this angle, I know the opposite and adjacent. OA, OA, TOA, SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. I know, it's fun. So that means I'm going to use tangent. So I take tangent of 3 degrees, okay, because you always put the degrees next to the ratio. Opposite, 1707 over adjacent, x. So there's my formula, or my problem. And then as we went over in some of the other videos, the way you solve this is simply you're actually going to divide 1707 by tangent of 3. And so this will just work out live just to watch it work. So we're going to do 1707 divided by tangent of 3 degrees We get that number 32,571.5. Now, if you look at the 1707, that's in feet. And if you read the problem, it says how many miles. Usually a plane will want to know how many miles it is from the airport when it lands, not how many feet. It's too small of a unit. So this is the right answer. We just need to convert it into miles. So what you do here is you just divide it by however many feet are in a mile, which is 5,280. So if I divide my large number of feet to the airport by 5280, I get how many miles it is to the airport, approximately 6.2 miles. And so that's the solution for this. At 6.2 miles, the plane will begin its 3-degree angle of descent and land smoothly at the airport. Hopefully no coronavirus cases on board. Okay, so again, the 3 steps: draw your picture, set up your correct trig ratio, and then the only last little trick here is always check your units. A lot of these will be word problems, so you want to pay attention to your units, no naked numbers, and make sure your units are in what the question is asking for. Okay, so then just one more question on this homework, which is what common mistake can be made when you're doing an angle of depression? And what I see a lot of people make the mistake of is they do not correctly identify the angle of depression. Just to draw this again freshly as a new sketch, what I see a lot of people do is they'll say, okay, here's my airplane. I'm going to draw it fast so it's not going to be quite as good of an airplane. Here's my airport, and they'll say, okay, the airplane's going down to the airport, and they'll draw their right triangle. They'll draw it like this, and they'll say, oh, that's 3 degrees. And they'll misplace, not 30, but 3 degrees, and they'll misplace their angle of depression. You can go back to the definition. What's wrong with this? Well, an angle of depression is always the angle formed when it comes down from a horizontal line. This is coming up from the vertical. This is not a 3-degree angle of depression. The angle of depression has to be coming from here. Okay, and so that's kind of the mistake I was, can't quite see that. That's the mistake I was pointing out down here, that 3 degrees, you got to correctly place your angle of depression. Don't put it next to a vertical line. Always make sure it's coming down or up if it's elevation. But I usually see this as a problem with angle of depression from the horizontal line. So just watch out for that. If I wanted to use this triangle, again, as I've shown you here, if I wanted to use this triangle, I can find this angle and use it that way, because this is a 90-degree angle. So if that's 3, this is 87. And if I want to use this kind of a triangle for, say, this airport problem versus this triangle, either one is fine. This one uses the 3 degrees as it is, as an angle of depression. This, I just need to use 87. And this would be my 1707, because this is still the height of the airplane. And this would be my x, because this is how far you are from the airport. But now I would use 87 degrees, and it would change your ratio, opposite over adjacent, but you would get the exact same answer. So be careful, angle of depression. Make sure you correctly place it from the horizontal line. Okay, I'll see you on the the classwork for 8.4. Have fun.